Hey folks, how are you doing today? Welcome to another session of the ASQ Lean Enterprise Division webinar series. This month, the topic is what doesn't get measured gets done. Steve Hahn is going to be talking to us about that. I'm going to let Steve introduce himself. I'm going to make him the presenter now. And so, Steve, feel free to take it away. Let me know if there's anything you need.
There we go. Thank you for that.
There you go. Very good.
All right. Welcome, everybody, to this ASQ webinar on time study. My name is Steve Hahn. I'm speaking to you from Philadelphia. I've been in operations for 30 years now, spanning project, physical production, transactional production in a graphics art studio. I'm now involved in actually doing quality improvement work in a mail order pharmacy. So my experience, I've been able to apply my lean interest and knowledge to a lot of variety of applications, and I look forward today to provide a little bit more information on some of the ways we look at waste in a process. So today I want to talk about time study. We'll give you a little background on what it is, why we do it, a little information on how to set up a time study, as well as some typical results that you can get from various time studies. So we all know the tagline, what gets measured gets done. But is that always the case? You know, in a situation where you're looking at cycle time, it really depends on the accuracy of your standards and the measurement system that is used. And when I talk about accuracy of standards, we're not just talking about how accurately am I ever to be able to measure the start and end, but really I'm looking at how accurately does my standard depict the value added component of the process. And of course, we all know measurement systems can introduce error, and that's another fact that we need to work through to make sure that we do know that what gets measured gets done. Most of us are in profit organizations, and we're focused intently on our throughput and our operating expenses. That means that we have to have a good handle on our capacity and our efficiency. For those of you who happen to be in a situation where profits are fairly stable, and you don't need to be as closely monitoring your capacity and efficiency, I would say just wait, things are about to change. My experience over the years is you never know when it's going to happen, but when one of your main customers decides to move away, you have new competition come in, or you have an opportunity to expand into new business. If you don't have a good system of measuring and controlling capacity efficiency, you're going to be struggling at that point to really manage your profits. So for those of you that are already intently on this every day, good for you. For those that maybe haven't had to spend that time on it, I suggest that you think hard and fast about doing the work to make sure you do have that good understanding, because you will need to know that sooner or later, I guarantee it. So as you focus on capacity efficiency, there's really one item that is common to both, which is time. So understanding time is really critical to having a good understanding of your capacity and your efficiency, which we know with that you have a better chance of improving your profitability and maintaining stable profitability through changing circumstances. Thought Henry Ford actually put it really well when he talks about time waste. Time waste cannot be salvaged. It is something that once you lose it, it's gone. It's not like regular rework where you can fix it. And it happens to be one of the hardest things to see because it's not very visible. So it's not readily visible to you, and mostly, I would say most of the systems that you have in place to measure time and monitor time in your factory or your organization probably doesn't do a very good job of really highlighting the waste in your process. So a thought-provoking question for each of you would be, how much time is wasted in your operation? Do you really know? Another way of looking at this, in my experience, most people, their productivity or capacity or cycle time standards are usually based on historical performance. And we know over time, waste has a way of working its way into our processes. And so when we use those historical trends, to set our standards going forward, all we're doing is perpetuating that waste. The only really way to understand the waste in your system and the waste in your processes is to do time study and to analyze your measurement system as well as your processes. And that's what we want to talk about today. So what are the benefits of time study? Time studies can help you in a lot of different ways. If you're in a situation where you have a growth opportunity and you have to add capacity, well, how much capacity do you have already? How much capacity can you realign to this new growth and not have to expand in the expense of new hire? If you happen to be in a situation where you do have intense cost pressures, you really need to understand your efficiencies so that you know where that waste is and what you can pull out of the process. If you happen to be in a development cycle, it's very important to know where you're going to spend those development hours and make sure you're developing the right capabilities that are going to give you the maximum benefits. In addition, once you've implemented those benefits or implemented those changes, you want to make sure that you're getting the benefits that you expected to realize. So just some examples of what we've been able to see with the time studies that we've done. Just by focusing in on one area of the process, we've been able to increase the throughput of the entire process by 6 to 8%. And that was done in a situation where our constraint was in scheduling. We had a difficult time scheduling orders on time to maintain the flow on a monthly basis. By improving our scheduling efficiency in just that one work center, we were able to improve the throughput through the entire organization. Those efforts that we applied to improve the efficiency in scheduling also applied to the rest of our call center. And by taking additional countermeasures, we were able to actually increase the productivity of the overall call center by 10-12%. That 10-12% was a reduction in average handle time, which reduced the need for labor, which we were able actually to apply to a new growth opportunity that we had. That 10% reduction in call time amounted to about 40-some seconds, also impacted the customer. If all of us have been on the phone with our call center, and we know what it's like to sit and wait on the phone call or answer redundant questions and so forth. So taking almost a minute out of that phone call was a tremendous win in terms of the customer experience. And it also was a very motivating factor for our employees. Employees get very easily frustrated when they have to deal with the waste in the process and inefficient processes. By improving the process, we not only improve the customer experience, but the motivation of employees. And as you know, call center is a very difficult job. Anything you can do to improve the work experience for employees is helpful, not only for their extent, but also for your attrition rate as well. So the other thing that was interesting is the improvements that we made really did not require a lot of capital expenditure. Over 80% of what we had to implement were really just process improvements that were not dependent upon system or technology. Only 15% of what we did to make these improvements involved actually capital expense. So as you can see, even though the changes and the effects of time study affect certain areas of the business on the shop floor or your office floor, they have high-reaching impact over the entire organization, allowing the organization to grow and remain competitive in our changing environment. Of course, time studies will identify the opportunities, but those opportunities need to be remedied with countermeasures before they're realized. And so here's an example of some opportunities that we uncovered in some time studies that were done in the call center. You can see these opportunities, they resulted in about 70 seconds worth of potential improvement. And they involve your typical situations of handoffs, rework, waiting, and wasted intellect. We were able, through some very simple, intuitive, easy to implement countermeasures, reduce that time by almost half. Now, we did use some automation in terms of that transition time to the nurse. We did some automation to make sure that the customer information carried through with the phone call, so there wasn't the need to do any revalidation. But in order to reduce Hold times, we just had to do some revisions to our schedules to make sure we had the right people in at the right time. As far as needing to reach out for support to a supervisor, we were able to identify the very specific skills that were required, requiring that handoff, and do some upskilling to make sure to avoid that continuing in the future, as well as increasing our process audits to make sure that people were following the process. We actually had a new capability introduced that identified the patient or the customer's name to our agent, but some of the agents who have been in service for quite a while still were following the old process and repeating information to the customer that they didn't need to. So by providing some additional training to them and some awareness training of the new changes that were implemented, we were able to eliminate that time as well. So as you can see, the opportunities generally don't rely on a lot of complicated, expensive countermeasures to resolve. Most of them are just do it actions and can be done easily by your operations folks. Now, as I stated, when we talk about cycle time standards, we're talking about the value-added cycle time. And so what we want to do is focus on that waste in the process. So as we observe the processes, we are focused intently on identifying those non-value-added components to the process, not just identifying how long the time it takes to do each piece, but also the value-added component. Additionally, we're also looking at idle time. Most of the planning variables that are used are rate-based, which are more of a quantity per hour. And people tend to assume that that quantity per hour is what's produced if somebody is working 100% on the work at hand. But we all know that their idle time is required for employee rest, but also because we have delays in the process. So we also involve the idle time in our time studies to make sure that it's within acceptable limits. And if there's any delays that we can avoid, that we can go ahead and take some effort to reduce or eliminate those. Expenses are also include not only productive time, but that non-productive time or shrink. So in some of the time studies we do, we actually not only look at the cycle time and the productive time, but we'll also look at the entire time the employee is being paid. And by looking at that, we can make sure that there could be some errors in your measurement system that's not quantifying the shrink properly, and also just make sure that the non-value added time is within the acceptable limits based on your company's policies. We find that often it takes a set of fresh eyes with some knowledge of being able to identify waste to do this effectively. And so we want to make sure that as we come in and do this work, that we have those folks available that have the training that can do this, identify the waste that in a lot of cases the operations folks are not able to do. A lot of the audits and quality audits that are typically done are really focused on the customer experience or just compliance with a written procedure. They're not always looking at identifying the waste. And so we can bring in those experts that can help widen the view and open the eyes to that. We take a classic lean approach in doing time studies. If you know the 8 wastes, you're perfectly capable of doing this. We know those wastes are always evident in our processes. In fact, that we find on the processes we've been looking at, a good 10 to 20% of waste is almost a given in every case. So by bringing those people that understand waste, you're able to make that waste visible. And I would venture to say that most people on this call or in the companies that you work, you have the expertise to identify this waste, and you have the capability of doing these studies using your in-house resources. So there are several types of studies that we do. We do a strict cycle time study, which again is just looking at the activities between the start and finish. It could be the entire process or just a part of the process. And again, this is a very useful exercise to establish and create your standards. what are the current steady state or your current state standards, and then what could they be if you eliminate that waste? Which standards should be we working to? Now, frequently when we do those studies, we uncover quite a bit of waste, and the standards that we are producing don't line up with the current capacity planning model. And you can imagine capacity planners are not going to just change their productivity standards based on a single study. They need to see evidence, and they need to see proof. They need to believe. And so one of the things that we'll do is we'll do what we call a productive time study. Is we'll take the cycle time that we create, that we measure, and we will map that to the variables that they use to capacity plan. Most of the time, we see these folks are using rate-based, like quantity per hour rates. And if you take our cycle time and you just convert that to a quantity per hour, the rate is extremely high because it doesn't take into that account the idle time, and also it eliminates the waste. So we can actually, by looking at the employee, what they do throughout the day, all their transactions with the time management system as well as the production system, we'll gather that from an observations. We'll gather the printouts and the raw data from the measurement system, and we will compare those and actually be able to explain what the differences are. So if anybody has any doubts about the validity of what we're producing, we can generally avoid and get through those just by showing the details of how the two compare. Once you've got your processes relatively stabilized, or at least that we're working towards these new standards, people start getting some confidence in the work that you're doing. We often then get asked to and get the opportunity to do a waste analysis. And the waste analysis is actually the one that I find the most interesting and the most rewarding. In a waste analysis, we'll actually do a second-by-second review of the process at hand and evaluate each activity in each moment in time as value-added or non-value-added. This is particularly useful for the developers who are looking for opportunities and waste that they can eliminate through automation. It's also very useful to the operations folks, as it highlights a lot of the behavioral and kind of just things that we do in the process that don't make sense. We're able to identify the waste, the different types of waste, but bring it right down to the actual activity and what part in the process and what the employee is doing at the time that the waste occurs. Not all of it is actionable. Always, we know that there's some waste that you cannot get rid of, but we usually provide it all, and we let the consumers make that judgment, not us. One thing I will say is, as you move across from left to right here, the amount of effort increases. Waste analysis is quite labor intensive, so we don't do those quite as often as we do the cycle times in the productive study. So how do you get started? And then really that depends on each individual situation. You know, as we said before, you know, if you're in a development cycle and you need to identify some capabilities some waste that you can eliminate with capabilities, cycle time studies will generally do that. The cycle time study not only identifies the cycle time, but at least the low-hanging, easily identified waste that you can get rid of. If you've got a capacity planning issue, again, I would start with the cycle time, but then I would move into a productive time, because again, those capacity planners need to understand how what you're measuring compares to the variables that they use. So it really depends on your situation. I would say in almost all cases, we start with a cycle time. They're the quickest and the easiest to do. They can validate your current standards, give you an idea of how far off they might be, and also give you a real quick heads up on some of the low-hanging fruit, the waste that you can eliminate. And I would move to the right and do that waste analysis. Once you get into more of a continuous improvement mode, and you want to start doing ongoing improvements, you would do those waste analysis. We have started to do some of the waste analysis on like a biannually or annual basis. because there is a lot of information that comes out of those, and it can take some time to fully absorb and react to it. But if you do it on an ongoing basis, you can actually kind of re-baseline and understand how your processes are morphing. As in any project, the first thing you need to do is to make sure that you engage with your stakeholders. We started off by doing time studies, engaging with the middle management and with the operator SMEs, and we got some very limited results. However, when we really started with the senior leadership and made sure that where we were, the areas that we were going to study aligned with their high-level priorities, it made all the difference in the world. Obviously, once you get the senior leadership support, getting middle leadership support is much easier. And you need those middle managers and supervisors because they manage the labor, they control the labor that you need to do the study. They're also the guys that have to deliver on the results that their senior leadership is presenting. So anything that you can do to provide them with tools to help them do that is beneficial. Quite often they can be a little defensive when you first show up, thinking that you're going to start pointing fingers and rearranging everything you're doing. But we can take the time to make sure they understand that we are truly there to help by listening and make sure that we take on board all the things that they are concerned about and all the factors that they're aware of. Once they get on board, it makes things very, very smooth. And I will say, one of the things that we definitely have learned too is when you're doing your time studies, when you're talking to those middle leadership and the senior leadership, you want to talk in terms of dollars. When you're talking to the support guys and your operation folks, you want to talk in terms of seconds or minutes or time. When we first started talking to middle managers, telling them we can save them 10 or 15 seconds, we wouldn't get a whole lot of result. But when we dollarized it and told them it would be 150 or $500,000 worth of savings, amazingly they started paying attention. You also need to get those support guys involved. Your planners, if they're not willing to take your revised cycle times and standards and incorporate them into the capacity plans, then you're really not going to receive the benefits to the bottom line. So we always bring them on board up front. We make sure that what we're measuring is going to be directly related to how they set up their planning models. We also get a lot of their input because they know how the work is measured, and we want to make sure that as we're measuring it, it's done in the right way so that we're matching up with the various cues and so forth that are being planned. Obviously, the process engineers are important because many of the changes that we do come up with require a little bit of process engineering. Some of them are definitely automation or technology based. What we find, interestingly, is that the process engineers are usually our main requester for these studies. They are just so hungry for information on where to go with the next capability. What's the next thing I need to implement? And so we really don't have a problem getting them involved, and we actually use them to help us to keep the rest of the folks involved as well. And then obviously you have your SMEs, your operators. Those guys are very important. They know the process. They are really the process experts. So when we're designing a study, which is you have to be very deliberate on how you design your study, we talk with them. We get a lot of information from them. They help us understand where the landmines are that we need to avoid and watch out for. They are very good at helping training our observers so that the observers have a good basic understanding of the process in terms of what they're going to be observing. And we find that they're extremely helpful once we are finished the study and we do the analysis, to go through the analysis with them and get their insights and understanding the different wastes that we've identified and truly understanding the difference between what might be a avoidable waste and what's a non-avoidable waste. Sometimes there's a very fine line between the two, and the operators are very helpful for that. And we also find that once you get the operators and your process SMEs to really support your results, it makes it much easier to bring on the middle management and others as well. So we bring in all stakeholders early and often to make sure that everybody's informed. Anybody has any questions or concerns, we address them up front. We find it's very, very important to make sure your studies are successful and the benefits are realized. There's a number of observation methods that you can use. I think most of us probably picture the person with a stopwatch and a clipboard standing next to you watching everything you do, or somebody sitting in the chair beside you. And we have done some of those. Obviously, in an office environment, you have opportunity to look at screens and things in other ways, and we typically move more towards a virtual type of arrangement. The on-site arrangements can get very complicated and expensive if you've got organizations that spread out very far, like ours. Requires travel and rigid scheduling, which is very difficult to really pull off. If you happen to be in a smaller company where you don't have a high variety of work, a lot of locations, the side-by-side would be perhaps a much better approach for you. But in our environment, and especially with COVID and people working at home, it's almost impossible to do the side-by-side. So we tend to do things virtually, either using the WebEx or Skype in real time. But what we really like to do is do it based on recordings. You know, the call center software allows you to record audio and video. We've also been able to provide licenses to people that are doing just transactional work at a desk, and we can use that same software to record their work as well. So with the recordings, we're able to do the observations in a more efficient, flexible manner. We're also allows us to provide those recordings to the operations and development folks if they want better understanding of the waste and what's going on in the process. They can look and witness the waste for themselves. It depends on what you do. Even in a physical environment, I've used video cameras on tripods, and we've videoed work even if the work moves and the people move throughout the factory. We've been able to do that, or we've just set it static and watched this particular area to see what's going on, see how much of that time that they're there is actually spent value added versus non-value added. So you do have opportunities to use the video in a transactional and a physical environment. It just depends on what your need is. One of the most important things to consider when you're doing a time study is that you are going to take a sample of work, and from that sample, you're going to estimate the cycle time for the entire population of production work. And so you have to be very careful in how you select your sample. The sample that you select is dependent upon the variation you have in your process. In our particular case, we have dozens of different work types that are flowing through locations spread out across the United States. And we're constantly introducing new capabilities into our system. So we can't just go out and pick 5 people from a certain location and do a time study. We need to be very deliberate in understanding what the normal causes of variation in the process are and what the special causes of variation in the process. For those normal causes of variation, we try to pick our sample so that we randomize those. For those special causes, initially we try to avoid them. So things like, oh, we're running a new product through for the first time today, or next week we're implementing a new process change, or by the way, next Friday we're bringing on a new class of 10 people that are just getting started. Those kind of things, those real obvious ones, we will definitely avoid when we're setting up a design study. But there's a lot of other cases where it's not that obvious. You know, for instance, if you want to study work that might have 14 or 15 different work types, you need to know, are they batching that through, or is it coming through in a random order? Depending on how the work flows, will definitely need to be considered in how you choose the work that you're going to study. We also have new processes implemented, and we follow an agile approach, so you get bits and pieces of it introduced into the workflow on a somewhat random basis, and you need to be aware of that and account for that when you're doing your design studies. So what we do is we typically meet with our SMEs and our middle managers. We go through a root cause analysis, just like you see here, to help them identify what are the things that we need to take into account when we're doing our study. Those things we can randomize, we'll build that into the design. Those factors that we can't randomize, we'll collect metadata on so that we can provide insights to the impact of those different factors. And often we can either filter out data based on the factors that we collected, or we can do some weighted adjustments to the cycle time to take the sample that we have and make it better represent the sample, the actual work being done. This is a very important step. Takes a lot of time the first couple times you do it, or it's a little awkward. But once you do it a few times, it happens pretty quickly, and you have a kind of a general set of conditions and factors that you need to look out for. This is an example here of a case where we were doing a study on an intake function where the folks were taking faxes, they were imaging them into the system, and they were creating customer profiles. We were told that everybody, all the workers were homogeneous, and you could just pick whoever we wanted to pick, and it would be no problem. But when we started looking at the variation in the work through the process, we noticed it was extremely high, more than we could explain. So by digging in and getting some data on the actual employees and their relative performance, we were able to create a frequency diagram, and lo and behold, what we found out was we actually had three tranches of employees. We had the employees who were very well competent and skilled in the process. We had a set of employees that were actually relatively new to the process and were still learning, and their times were higher. And then we had a set of employees here at the tail that actually only worked on very specialized work that had a high labor content. So if we'd taken a random sample across this entire population, chances are we would have gotten a cycle time that was much higher than what it should have been. So what we did is we really excluded these employees that were what we call special causes and focused on the process, the normal causes of the process, and we just looked at these folks here. But you can see these folks, their cycle times are in the 340, 360. Out here we're in the 430, 460. So had we not done the work to understand the population and made the right choices that we did, we could have been easily off by 50 or more seconds in our cycle time estimate, which could have been catastrophic for the business if they were making any plans in the future on that. So what I'd like to go through now is some typical examples that we see from the observations that we've done. So we talked earlier about wanting to understand what the cycle time is, but also wanting to know what that value-added piece is. Now, so this particular study here, we were looking at average handle time for, again, those scheduling calls. And this was requested by our process experts, and they really wanted to know, we didn't want to care about after-call work, we just want to care about the talk time with the patient or the customer. And so we divided out the cycle time here. This is what it is without the after-call work. This is what it is with the after-call work included. The interesting thing about this study is we actually found one of the main contributors to cycle time occurred in the after-call work. What we found is the employees were not returning themselves into the call queue following process, which ended up creating extra idle time for each of the employees. So had we not looked at the entire process, we would not have found that. And that was a relatively easy thing to provide some countermeasures. The system actually did not default people back into the queue. The system right now is being changed to make that default, so people will be automatically put back in queue after about 4 seconds or so. Again, without taking a holistic view, would have totally been missed. And we find frequently in time studies, the results we get are so counterintuitive. It's the things that people would never think of that we uncover. Here's a case where we were looking at the cycle time, and we divided it by tenure. And so you can see our cycle times here for the folks that had 90 to 180 days, and then you can see the cycle times for the folks that were 180 to 364. Now you would think that your more tenured folks would be more skilled and able to perform the task at a faster rate, but that's not what we found. What we actually found was that some of the new capabilities that were introduced, the older folks weren't adopting them, and they were still resorting back to their normal process. So there again, once we were able to determine that and what they were doing wrong, the operations folks were able to develop some additional coaching and training to work with those folks to get them to feel comfortable to use the new capabilities and reduce their cycle times. When working with the developers, a lot of times what they really want to know is, I just want to know how well my system is working. I know that the whole process has to be capable, and then there's a whole component of how the employees interact and their skill levels impact that. But for me to know that I'm making the right moves into my system, I want to know what the system can do under kind of best conditions. And so what we've done is we've broken out our cycle time sample into quartiles. The systems guys tend to focus on this first quartile, which is generally your folks that are using best practice and using the tool to its maximum capability. And so when we do time studies, we'll usually do a pre and a post enhancement and then some baselines. They usually focus on that first quartile to understand what the system capability improvement was. The second, third, and fourth quartile is really more of interest to the operations folks, because now what they need to do is they need to understand the behaviors of their workers and move them all towards the best practice and upskill them to make the best use of the tools that they're given. We talked about the fact that we may have multiple work types going through the process at any given time. And the way our process is set up, this work comes through in a randomized fashion. So we're able to break down the cycle times by product as well, so that you can see the different impacts of the different product types. And this becomes more important when you're looking at acquiring some new work, or if you're noticing some mixed changes in the work that you're producing. You can use this to better estimate future requirements if you know what those mixes are or what they're going to be. Some additional examples here is a case where we introduce some automation to identify caller, kind of like a caller ID. We call that our Annie. And you can see the difference in cycle time when the system is able to identify the customer versus when the agent has to do it on their own. So this is really good, again, for those developers to understand, hey, we put in a change, how much improvement did we get? Did we get what we thought we were going to get? As I noted earlier, we follow an agile development approach, which means you get a lot of piecemeal improvements interjected into your process. And as those different piecemeal improvements get introduced, the employee has to remember all these different ways that they need to work to maximize the new system. So what we find is different employees are able to utilize the new capabilities at different rates. And for those that aren't utilizing new capabilities, they're still having to revert back to use other ancillary systems to produce some of the work. Oftentimes what we're doing is we're adding in capabilities to our system that were maybe done in another system, so that we can avoid those transfers or those transitions to other systems, which is just introduce waste into the process. So by keeping tabs and being able to tell the operations folks how their population workers is swiveling to these other systems, we're able to understand how well these changes are being adopted and provide guidance for the operations folks, again, for that coaching and awareness training to get their folks comfortable for using the new system and weaning them off the old system so those systems can be sunset. And then finally, we're all aware of system lag and system response time. This is an interesting one. When we first started doing these studies, we would find response times that were averaging 5, 8 minutes or 8 seconds a call. And the thing about that is that's average per call. So if it only happens on half the calls, that means some people are experiencing a 16-second delay. Well, the development guys came up with their own version of the 5-second rule, and they tried to convince everybody that 5 seconds was as good as you could do. That if it was a delay of more than 5 seconds, they would look at it. If it was less than 5 seconds, that's just the way the system worked. Well, you can imagine that wasn't received very well. We've all been on the phone, and if you haven't, a 5-second delay when you're on a call with somebody seems like eternity. So needless to say, the development folks have spent a lot of time working on this and continue to make improvement. It's really, the causes are many, whether it just be the time it takes to interrogate different systems to get the data. It also has to do with your screen layouts and how much time people have to to scroll through screens to get to the data, or how many screens they got to click through. When they land in the screen, do they have to scroll to get to where they really want to go? We had one case where we provided a list of potential customers who could have been calling due to this anti-match. And the list was so long, and it turned out the ones that truly were most likely to match were at the end of the list. And it was so prohibitive for the agents to go through the list, they didn't even use it. So we got no benefit from our first cut through on that implementation. But through this study and through that observation, you're able to find those things and quickly react and make changes to realize the benefits. The other type of studies we do is those productive time studies, and I apologize, the slide's a little hard to follow, but you know, our capacity planners speak in terms of quantity per hour, QPH. What we're looking at is cycle time. We really want to know how long does it take to do the process. So when we take a cycle time and you just convert it to QPH, it's often much higher than what is in the plan that the capacity planners use. And that's for a variety of reasons. One, we're also removing some of the waste, but also because QPH includes idle time, cycle time does not. So typically what we end up doing is in a productive time study, we catalog and observe the entire day that somebody works. We look at we record all the production that they do. We also record all the times that they interact with the time management system. So we are able to take the cycle time that we calculate, convert it to QPH, and compare it to the QPH that is reported by the system. Now, in this case here, our system was telling us that our QPH was 5.3 per hour. When we watched, we observed 4.5 an hour, a significant difference. Now, there was some idle time in here that was somehow commingled into the productive time because the employee did not charge their time properly. But the most significant thing we found is our system was double counting. In some instances, it was giving people twice the output that they really produced, and which amounted to an overstating of our capacity by 25%. So if we were to use any of this data in our capacity models to project resource requirements in the future work or future growth, we ran the risk of being off by a significant amount. And this change here, once it was made visible, was easy to fix. Didn't take long for them to get into it and figure out what was going on, and it was easily corrected. But had we not done the study, this would have been perpetuated till who knows when. So the productive time study, even though it involves quite a bit of observation time, if you have people that don't understand the cycle time and how to use it, it's the way we found to help them understand why it's different and what needs to be done to bring it into conformance. And then finally, we talked about the waste time studies. This is an example of the top 8 wastes that came out of a study. And so you can see here, it's just a simple pie chart. You can see the first time here, we're looking at time spent transferring a caller was accounted to 34 seconds. No value being added. We're just moving the caller from one person to another. You're looking at waiting for another employee to respond. Often when you're reaching out to a second level support to get an answer, they need to do some research. So not only are you waiting, but the customer's waiting, and then for that answer to come back. So, you know, we're able to highlight those at a high level, but for each one of those, we also have the information. You can dig down into the process. You can see exactly where in the process this waste was occurring, what the employee was doing, and why. So it's very, very detailed information that helps you do your root cause analysis and countermeasuring. So as a couple examples here, this time transitioning between screens was that example I talked to you earlier. It was just really redesigning the screen so they didn't have to hop from screen to screen to screen, and putting the information on the screen so it was the order that they needed it to better match the way they worked, not the way the developers thought they worked. And of course, rearranging that list so that it was providing the most useful information to them. And then this excessive time using an inefficient method. This is a case where I think I talked earlier. The system provided the information to the agent on the customer's name and information. The agent would ask the customer to to communicate to them their information. They would look on the screen, see it matched, and they were able to go forward. But a number of the employees were still reading it back to the employee, once again, reading it back to the customer to confirm and clarify like they had to do before that new capability existed. So by monitoring that and doing some coaching and auditing, we were able to reduce that time, that waste of time as well. So this is just one slice of the data. There's quite a bit of opportunity that comes out of a waste study that can be actioned. The real key in a waste study is to make sure that you prioritize properly and go after the right pieces. So we've talked about why and what you get for studies and how you do it. These are really the key success factors to remember. When you're setting up to do your time studies, make sure you are aligned with business goals and you're aligned with your key leaders in the commitments they're making. Make sure that your consumers, those SMEs and those frontline managers, are involved from the very beginning, so you can begin getting their commitment right from day one. Make sure you have a clear definition of the work studied. So many times we talk about, well, we're measuring, what is a completion? Is it a touch? Is it actually a finished work product? There's a lot of definitions. You have to be crystal clear on what you're measuring, what the exact starting point and the exact ending point is, the process that you're measuring. There's so many different definitions for and acronyms used. You need to be really anal about that to make sure you get it right. Make sure you know how the business intends to use the data so that you have the right degree of accuracy and it's put into the right format. Make sure that randomized sample is a true representation of your work. Put the time in to really understand those factors that you need to take into account when you design the study. And then finally, your observers aren't going to be process experts on every process, so we calibrate not only to each other but to the SMEs to make sure that the information they're producing is accurate and useful. We minimize any bias. So the key here is preparation is required, and that is really the key to a successful time study. And so, in summary, time is a very valuable resource. It's difficult to see, and once you lose it, you can't repair it. Your current productivity standards contain hidden waste, whether you can see it now or not. The best way we found to uncover that waste is to do these work observation time studies. If you do them correctly and you align your business around them and you realize the benefits, you will see a result in your capacity and your efficiency, which ultimately leads to higher profitability. In the end, you can be confident that what you are measuring is, in fact, what's getting done. Thank you very much, and I'll be open to any questions that anybody might have at this time.
Sorry about that. I was muted. Actually, apparently I've had a bit of a muting problem. There were some people complaining about echo, and I realized that my mic was open, and we think that's what it was. So apologize for that. So I do have a number of questions. We certainly have time for more. And if we don't get to them, then I would encourage you to email Steve directly. Steve, hit the next slide, would you please? While you're doing that, I'm going to tell you that I'm working on a project now. And while I wasn't involved with this aspect, the director of a telephone group, in this case, they're trying to source work orders by phone. The director and his manager watched the people do this for 2 days. They did a 2-day telephone study back in March, and they're still working through the opportunities that they discovered. And I mean, some of it was as simple as, oh, there's coaching opportunity for language to use with vendors, because depending on how you present something, they might be upset or they could be happy. And so, obviously you want to present it in a way that makes they'll walk away from the conversation happy. So going in, seeing what's going on, it's amazing how even the leaders of the area don't really know until they see it. So Steve, that's great. And you've mentioned that a few times. So we had a question early on, and it was, are the observations that you're getting distorted by the Hawthorne effect? And I'll be happy to explain that for anybody who needs it if they're not familiar already.
Yeah, so we actually have seen that. I've actually done some research to try to find out, is there is there any kind of rules of thumb on how much impact you get in there? And I haven't really been able to find a whole lot on it. But we do see that. In one of the earlier studies we did, people took no breaks. They just worked like machines. This is when we were standing behind them with the clipboard, and yeah, they were working away like crazy. Obviously, that's not sustainable. So we had to make some adjustments for that and make sure we included some idle time for them. So it is a factor, and that's one of the reasons why we like to do the recordings, because we can kind of pull that out of it.
You can pull back so that you're not part of their visual field. I mean, they're not worried about being watched, right? Yeah, pretty quickly with cameras.
Yeah.
Okay.
Yeah, and it's funny even when we tell them, hey, look, we spend a lot of time when we do face-to-face. It's not about you. It's about the process. We want you to do exactly what you would do on a normal day. And no matter how much you try, it seems like they just can't help themselves. Yeah,
so I'm an industrial engineer, Steve, as you probably know, which means that I've spent most of my career watching people work. And I got to tell you, it's sort of amazing, because you can tell people, oh, you just pretend I'm not here, but like they hear you breathing, they know. I'm amazed that more people freeze up. Do me a favor, hit the next slide, would you please, with your contact information, if you could. I mean, I love that quote from Taiichi Ono, but so there's some of Steve's contact information. Also, folks, just so you know, not only did I chat out all the links that I mentioned at the start of the broadcast, so go into the chat box and you can find links for the next couple of webinars, plus ASQ's Lean Enterprise Division's YouTube channel, as well as the fourth one, which was Steve's contact information. I also included those links in the handouts. So if you need them, then you can certainly go to the chat and or the handouts. It's the same information, just depends on what you like. We got a comment that said, it's a true lean person, obviously. I love when we start measuring something and it completely goes against our assumptions. It's really neat to see things like that. The example of the cycle time being longer for more tenured employees is an example of that. It's a good reminder to check our assumptions. Thank you. So I don't know if you want to comment on that at all, but
no, I would definitely agree with that, and I would say that it's very rare that we do a time study where we don't question this, or challenge assumptions.
Sure. Okay. Another question is, with regard to time study, how can you observe a worker's time when that person is performing several SOPs, maybe at the same time? How do you handle that if it's not all in one procedure?
Well, we can choose any start and end point we want. So if they're doing something in sequence, it's fairly easy to do that. But I would say a call center is actually a good example of what you're talking about, because in a call, the process it is truly one SOP, but you have identifying the customer, you have identifying their need, you have resolving their need. Then there might be some kind of mandatory things that you need to check through that the patient doesn't even know that you need to do. And it can happen in any order imaginable. As much as you try to script that call flow, the patient will take you down whatever direction they want. And so when we get into something like that, that's where sometimes we have to get into those recordings, and which allows you a lot of flexibility to try to pick and choose of your STEM points and try to identify what they're working on at any given time. It's also important to have your SMEs involved, and we'll actually bring the SMEs in, and they will simultaneously review with our observer. So we're getting the benefits of understanding the waste, but understanding the process at the same time. But if you've got processes that are being completed in parallel, and they have their own cycle times, I'm not sure how you would measure that. I'm not sure how you'd even plan that. It almost seems to me that you would be better off rolling that into one activity from a cycle time standpoint, and not each one. But if in fact there's one piece of the process that you want to look at, maybe in your case it would be one SOP, we do that frequently for the development folks. There's one piece they want to improve. We will focus on the beginning and end piece, that one piece by itself, and give them results of that.
Gotcha. So you might wonder why they're using several SOPs. Maybe it should properly be one. So, okay, good. There's another comment. It's a question, but I'm going to take it as feedback for us running webinars. And it's the question, can you add a key or definitions from acronyms in the presentation to be added to the end, like in a glossary page? Sure. Certainly Steve is not able to do that right now, but I will take that under advisement for the future and talk to future presenters about that. So great suggestion.
Yep, good suggestion. Thank you for that.
There was another one. Can these principles be applied in companies that offer services such as clinics as opposed to just calls, I guess? So can you do time study when you're actually watching work get done? I think is what they're asking.
Yeah, I mean, I don't see why not. The principles are the same. I mean, the conditions are different. I mean, in terms of healthcare information and things like that you need to be aware of. But I mean, I don't see any reason why this approach wouldn't work. I think of when I was looking at some physical processes. We put up cameras. I mean, if you're able to do that, I'm not sure if you're always able to do that in a healthcare environment, but maybe in others. You can put a camera and you can watch the movement of people and the movement of your workers and see what they're doing and how they're interacting. Whether you need to look at screens and so forth, you can also, I would think, record those as well and pull all that together. I don't see any reason why you couldn't do this. You just have to be very thoughtful in terms of the way you're gathering data, not providing any bias or interfering with the work that's being done as well.
Sure, absolutely. Okay. Yeah, somebody else made a comment about CCTV footage. A couple of questions, and then we're going to have to cut it off after that. First, how would you recommend cycle time gets measured for employees who are handling products that require vastly different times for handling?
Yeah, so we have that right now. Now I don't, vastly different is a relative term, but we probably have 100 different products that are flowing through realistically. The variation in time is not tremendous, but it could probably be double depending on which product you're looking at, and depends on the way the work flows. Our work flows to us in a total random, uncontrolled fashion. So what we do there is we will choose a sample in time that's large enough that we believe we're going to get a representative sample. We will then check the mix of work we got, make sure it matches the mix of work that we do in production. And then if that mix doesn't match, we will do some weighting, to adjust our overall cycle time. Excuse me. The other thing I would say, excuse me, let's take a drink here real quick. In cases where the variation is just too large, then you're going to have to narrow the scope of your study and just study certain product groupings or families that are similar, and do your study and get your results there, and then combine that later if you need to have a kind of an overall cycle time for the whole process.
Sure. Okay. Couple of questions or comments about what to do in a production environment, especially when it's a long lead time or a long cycle time. They're giving an example of 3 to 4 weeks. I've got a client whose products take 2 years to get built from the time they get started. They're large. It's a military contractor. And the short answer to that is what you have to do is you have to then compress the scope of your study. You might look at very specific things that are typical. In this case, they do a lot of welding. So you might look at what's involved in preparing a welding surface, the clamping, the grinding, the whatnot, and looking at that. If it's common to all your different steps, or right, with a long cycle time, it just takes more time, I think, to get your answers because you've got to take it in small bites. Any quick thoughts on that, Steve? Because we are actually over time.
Yeah, no, I would agree. I would break it down into smaller components and then structure the time study of each one over some, a period of time.
Great. Okay. Tell you what, folks, really thank you. Appreciate you being here. Again, as a reminder, check the chat if you're looking for links for the next couple of webinars or the video on YouTube. If you're looking to contact Steve, here's his contact information on the screen. It'll also be on the presentation. My suggestion is just reach out to Steve directly. Ask him a question at the same time you request the presentation, and he'll be happy to do that for you. Again, don't forget too, if you want the links in a PDF, then you can look at the handouts section of GoToWebinar, and it's available. As always, there's usually one or two people who have trouble with RUs. I'm available. You let me know. Steve, on behalf of Lean Enterprise Division for ASQ, I'd like to say thank you for your time and your knowledge. It was really, really a great presentation. Thanks.
Thank you, and thanks everybody for your time today.
All right, folks, I know there's lots of choices for how you spend your day. Thanks for spending some of it with us. Hope you all enjoy the rest of your day, and we'll be looking to see you in a couple of weeks or next month. Take care now. I'm going to end this. Goodbye.